found question 3 kind of fun, and perhaps maybe it's not your idea of fun, but there's 6 expressions that are given, and I'm asking you which of these 6 are equivalent to 2x to the negative second power. And I didn't see a lot of students, I didn't see a lot of you do this, but probably, but I did see some. Probably the first thing I would do is go ahead and try to write this without its negative exponent. So I've got 2x to the negative second power. Notice it's all in these parentheses. What I perhaps might do is multiply this by, in parentheses, 2x to the second over 2x to the second. Of course, I'm multiplying just by the number 1 if you look at it, right? 2x to the second over 2x to the second equals 1. And why I selected that version of the number 1 is because I know in my numerator now I have just 2x raised to the 0 power, which is equal to 1. So in my numerator, I've got the number 1, and in my denominator, I have 2x in parentheses squared. Now that is 2x times 2x, and I'll go ahead and write it out. Right, there are 2 of those. 2x times a 2x. And of course, 2 times 2 is 4, and x times x is x squared. So my target is 1 over 4x squared. Anything below that looks like 1 over 4x squared is equivalent to the original expression. So again, I'm going to keep looking for 1 over 4x squared. Well, obviously right away, and this is convenient, b is 1 over 4x squared. So that's convenient. Another thing I noticed right away is if you look at my process of simplifying this expression, I had 1 over 2x, the quantity of 2x squared. Well, that's e. So I have identified that both b and e are indeed 1 over, they're equivalent to 1 over 4x squared. So let's keep looking here. Well, a is not possible, right? There's no way that, that would be like saying 2 and 1/2 are the same, right? So they're reciprocals of each other, but a is not equivalent. For c, if I was to take the square root of this, I believe the square root of this would be 2x squared. Yeah, because if I multiplied 2x squared times 2x squared, I would get that. So this ends up being 1 over 2x squared, but not 1 over 4x squared. So C is kicked out of the running. F is, sorry. I mean, I could see how that, if we didn't simplify this expression, the original expression correctly, I could see how F might be a mistaken value, but that is not one. And then our only other candidate is D. And actually, if I look at D, simplifying that with the giant 1 would probably be a good idea. I could write in my numerator 3x to the third, and in my denominator I might write as 4 times 3, that is 12, and then I'll write it in x to the third times x to the second power. And you can see each of these have a factor of 3x to the third. Well, what that leaves me is in the numerator there's the number 1, and in the denominator there's 4x squared. So this is, D is clearly the same as both B and E, and the same as the original expression. So D is correct also. So you should have identified B, E, and D as expressions that were equivalent to 2x, the quantity of 2x raised to the negative second power.